Hello students, welcome to the next lecture on the extreme values. Today we will discuss about when the extreme points is said to be saddle points, or else how you can find the maxima and minima. Myself Dr. Garg, working in the School of Mathematics, Sthapan Institute. You can simply follow this YouTube channel link Dr. Harish Garg, where you can find the various videos on the mathematics 1. Now, what is the objective of this lecture? We will see in this lecture how you can find the maxima and minima of the function of the several variable, that is more than one variable. This maxima and minima are basically of the two category. First is that you have to find the value of the local maxima and minima, and second thing is how you can find the absolute maxima as well as the absolute minima on the closed bounded region. For example, if I say how you can find the maxima and minima of this function, that is called as the local extreme values. On the other hand, how you can find the maxima and minima of this function over this region are there, and then you can see this region. If you draw that, this is my here, and you can see this is my closed region. That's why this is called as maxima and minima over the closed bounded region. In this lecture, we will firstly try to learn how you can find the extreme values of this local maxima and minima. What is the meaning of the local maxima and minima? If you have any of the function f of xy which is defined in the region R, and a comma b is any point inside it, then the function is said to be local maxima and minima at this point. When is said to be when you evaluate the function value at a comma b and the function value at all the other points of domain B. And when it's a maximum when it will be greater than equal to, and minimum when it's a less than equal to for all the other pairs of the x comma y. So this is the one pair x1 y1, this is the other pair x2 y2, and so on. So if you are able to find a such pair from the region R in such way there are these either of these conditions satisfied, we call as local maxima or minima. For example, or moreover, you can also remember the extreme points are also called as the relative extreme points. For example, here firstly a very simple example. Can you check whether this is the local maxima or minima? What you want to prove, that you want to prove whether this is less than of all those pairs of this, or it's a greater than of all those pairs of this. Then only you can say the maxima or minima. So firstly you can find the values of f of 0, 0. It clearly says that it's a 0. Now you find the value of the fxy. Now your target is to compare them with the help of 0, 0. We know that this, because it's a scalar value, it's always be greater than or equal to 0, and we can say this is 0 means that is f of 0, 0. What is the meaning of that? What is the meaning of that? F of 0, 0 is always be less than equal to x, y. What is the meaning of that? This point means that 0, 0 is the point of local minima is there. Now once you have the local minima point and the local minimum value is, you can substitute this value here, you will get the answer as 0. But this example is a very trivial example where you can easily find this as a local maxima or minima. But if you look about this function like here, then it is not an easy to prove whether this function is always be greater than of the some point or is always be less than of the other point. So now here the example is trivial example, so that's why you can easily find. But the example like of this way is not an easy task to prove that. In order to handle this, we will try to study the first derivative and the second derivative test for the local extreme values. Remember that whenever it's a local extreme values, we will use the first derivative and the second derivative. What is the first derivative test? If you have a local maxima or minima at the point a comma b and the first order partial derivative exists, then the first order partial derivative at this point a comma b must be a 0 is there. So this is the first derivative test for the local extreme values. Now once you have the extreme value, then your target is to check whether this point is a maxima, whether this point is a minimum, or this point is a saddle point. And moreover, this a comma b is called as the critical point b. Now under what condition you can set this point is a critical point? Like if you have any region R, if you have the point a comma b in the domain, inside the domain, then this point is said to be the critical point when these two conditions are satisfied. Number one is the partial derivative of function f with respect to x and the partial derivative of function y f with respect to y are 0, and second is either one of them does not exist, then all those points at which these conditions satisfied is called as the critical points. For example, if you look about this function, now check, since it is only one variable, so there is no need to do the partial derivative. What is the derivative of this? So here, now clearly says that what is the meaning of the x is 0? X is 0, what is the meaning of that? F dash is undefined. So it means this second property satisfied. Therefore, x is 0 is my extreme point, or called as the critical point, because f dash does not exist. If you look about this function, now it's a two variable. So what is that? Either partial derivative is a 0 and partial derivative with respect to y is 0, or the second property is at least one of them does not exist. So if you take the first partial derivative 0, can you find the value of the x from here? X is nothing but my -1, y is nothing but my 2. So what is the meaning of that? -1, 2 is my critical point. Clearly says that none of the point will satisfy in which partial derivative does not exist. Now when this point, like say this is a critical point, when this point is said to be the saddle point. So the any of the point a comma b in the region R is said to be the saddle point when you are unable to classify the points such that either f of a comma b either greater than of the x comma y, or for some other pairs it will be the less than of this. For example, if I consider here, clearly say that if you consider about the critical point, if you take this as a 0, it will give you 2x is 0. If you take about the partial derivative with respect to y 0, it means 2y is 0. So what is the meaning of that? X is 0, y is 0. So 0 comma 0 is my critical point. Now in order to check whether this point is a saddle point or not, what you can do, can you find any of the pairs, any of the value of the x or y such that this value is greater than and this value is less than? Yes, you can do easily. You can see what is the value of the f1 comma 2. What is the value of the f1 comma 2? It's a less than 0, it's a negative, which is less than of the 0 comma 0, while for some other pair it is a greater than 0. So both the points are belongs to the domain of the R2. So therefore for some pair it is a less than, for some pair it's a greater than. It means this point is my saddle point. But however, again this example is a very simple example, so you can easily verify it. On the other hand, can you check this point, that is, can you check this point is always greater than of this? If it is always greater than, then you can say this is the maximum. If this point is always less than of this, then you can say this point is minimum. But if you say this point sometime it's a greater than or sometime it's a less than, then it's a saddle point. Again, I again repeat that it's not an easy task for you to check whether either of these conditions is satisfied or not. So how you can prove that? In order to derive this, it is difficult to identify whether this point is a maxima, minima or a saddle point. To handle this, we will need the second derivative test. So remember, second derivative test is used only to check whether the point is maxima, minima or the critical or the saddle point. However, how you can find this critical point? This critical point is found with the help of the first derivative test, that is by using partial derivative of x with respect to 0, partial derivative of y with respect to 0. Now what is the second derivative test? So if you have the any of the closed region R and the any of the point a comma b inside it, then the function f is said to be the local maximum at this point, is said to be the local minimum at this point, and is said to be the saddle point is this whenever the first derivative of the f with respect to x, y and the function exists the continuous over the region R. And what is the meaning of that? This is the first derivative test holds. Then we can find the second derivative with respect to what is the meaning of the fxx, that means of here. So whenever this value is less than 0 and this value is greater than 0 at this point, then we can say this point is my maximum. On the other hand, whenever this first condition is reversed, that's a greater than 0, while this condition remains same, then we call as the minimum point. And the saddle point is whenever this condition is less than 0. But you obvious that it's a very difficult to remember these three conditions are there, because sometimes the students may think about that is whether it's a greater than or less than examination. It's not an easy task. So I will tell you the another method which is quite easier for you to remember this. That is, here you can construct the matrix of this. Now if you have the function of the 2 variable, then it is my 2 cross 2. If you have the function of say 3 variable, then you can define a function of the 3 cross 3, which is defined as fxx. First line is partial derivative with respect to x of xyz. Second is y with respect to x, it's a yy, it's a y of z. And the third one is z with respect to x, z with respect to y, and z with respect to z. If you have the 4 variables, then you can write as a 4 cross 4. Then we can define the two matrix that is called as the determinant. The first one is called as the fx. It is called as the principal minus b. Once you can compute the principal minus of this, what is the principal minus? The first diagonal entry called as the h1. Second diagonal entry, that is these two elements, determinant of these two minus b. If you have the 3 cross 3, then the third one is the itself here. Then we can check whether h1 is less than 0 or greater than 0. h2 is less than 0 or greater than 0. Then we can see here. Now, once you can define the h1 and h2, we can find the local maxima and minima. What is fxx? You can see this is here. We can say h1 whenever the first principal minor is less than 0. Second, so we can say whenever the first derivative, that is h1, is less than 0, h2 is greater than 0, that is the determinant of this, then we can say it's a maximum. If the first derivative is greater than 0, h2 is h2 that's always be greater than 0, then we can say it's a minimum. On the other hand, whenever the second derivative, that is the second minor, is less than 0, then we call it as the saddle point. And if this value is my 0, then we can say the test is inconclusive. So look at the various example how you can say so that you can remember it. Also you can remember that you all knows when you can say the function has a maximum value. We all knows when its second derivative is less than 0. So the second derivative, that is my h1. Whenever it's less than 0, then it's a maximum. When it has a minimum value, when the second derivative is greater than 0, that is h1 is greater than 0. h2 is must be the greater than 0, then it's maximum minimum. Whenever h2 is a less than 0 or the 0, then we can say it's a saddle point or inconclusive. Look about that. So now we have to check the extreme values, whether it's a maxima or minima. So we apply the first derivative and the second derivative. We can firstly find the critical point. What is the first derivative of this with respect to x? That is y minus of 2x minus of 2 is 0. With respect to y, we can say this is x minus of 2y minus of 2 is 0. Now after solving this, you can solve this with the help of the calculator. You can get the value of the x, you can get the value of y as here. Therefore, minus 2 comma 2 is the critical point. Now you have to check whether this critical point is my maximum, whether it's a minimum, or it's a saddle point. How you can do? We will try to construct this value. So firstly we can derive this. What is the second derivative of this function? It's a minus of 2 with respect to x. X of y, that is the second derivative of this, is by 1. This is again 1. This is my minus of 2. Now since it is a constant value, so but if it is, say, for example, if I say this is my x, then we have to substitute this value in here. We will see in the next example. Now once you can compute this matrix, then we can define the h1. That is the first value, determinant of first value. What is h2 is? Determinant of the first two diagonal entries. So here, what is the value of h1? It's my minus of 2. It's here. Clearly sees that h2 is my greater than 0, h1 is less than 0. So what is the meaning of that? When the second derivative less than 0, that is my maximum. So it means minus 2 comma 2 is the point of the local maximum. And the value is, you can substitute this value here, you will get the answer as 8. So these are simple steps. We will see in the next 7 to 8 examples more. We can find this value here. Okay, again you can check what is the extreme value of this. We can start with this here. What is the first derivative? This is y0 and here is x0. So therefore 0 comma 0 is my saddle point or is my critical point. Once you know the critical point, we can substitute here. What is the value of this? It's a 0. What is the value of this? It's a 1. This is 1. This is 0. Now what is the value of the h1? H is the first diagonal entry, that's a 0. h2 is my determinant of this. It is my minus of 1. Clearly says that h2 is my less than 0. Whenever h2 is less than 0, it can never maxima nor minima. So it means it is my saddle point. So therefore 0 comma 0 is my saddle point. Also you can easily verify this value. You can take the pair of 1 comma say minus of 2, then this value you can substitute here. It's my minus of 2 which is less than of this, but if you take the pair of the 1 comma 2, then it is my here. So clearly say that for some pair this value is greater than of here, for some other pair this value is less than of this, so that's a saddle point. Look at again, this again you have to find the maxima minima. So again we can start from here. What is that? Partial derivative with respect to x, so it is nothing but my y of cos x is 0. Partial derivative of this is called as the here. Now what is the meaning of that? From here we can say x is nothing but my n pi. When x is n pi, cos of n pi is always the positive, so it means it gives you a y is equal to 0. So what is the saddle point is n pi comma 0 is the saddle point. Now you can substitute this value here. What is the second derivative of this with respect to x? This is my minus y of sin x. This value is my cos x. This value is my cos x, and this value is my f of y. So it's my 0. Now you can see here. Now since it is a function of this, so you can substitute the critical point at here. So what is that? At n pi comma 0, you can see at n comma 0, so you can substitute here. Sine of n pi is 0, y is 0 here. Cos of n pi is my minus 1 raised power n here. Now compute the value of the h1, compute the value of h2. h1 is my 0, h2 is my determinant of this, it will be minus 1 raised to power 2n. Minus 1 raised to power 2n is always positive, so it is my minus 1. Clearly says that this value is my less than 0. What is the meaning of that? It is my saddle point. Since h2 is my less than 0, so therefore this point where n is my positive integer, so that is pi comma 0, 2 pi comma 0, all are my saddle points. Look what is another one. Extreme value again you have to find, so we can start from here. What is the first derivative? You can do this. Now you can easily solve this value. You can multiply by 2, this is multiply by 1 and so on. You can say after solving you get the critical point here. You can solve this value here. What is the second derivative? This. What is the value of the h1? It is my 2. What is the value of the h2? It's a 4 minus 1, 3. So h1 is my greater than 0. h2 is my greater than 0. So since this value is my greater than 0, it means this is my point of minimum. So therefore it's a minimum value, and the value is obtained by substituting the value in the given function as minus 5. Look at the another one here. Again you can start with this first derivative. So if you take the first derivative with respect to x, it's 2y minus of 10x plus 4 is 0. And if you with respect to y, it's 2x minus 4y plus 4 is equal to 0. Now you can solve them. After the solving you will get the answer as 2 by 3, 4 by 3. So therefore this is the critical point. Now you can substitute this value of h. What is the value of the h1? The first determinant is a minus of 10. h2, the determinant of this, it's a 40 minus 4, that is my 36. Clearly says that h2 is my greater than 0, h1 is my less than 0. So since it is a less than 0, so it's a point of local maxima. So once it's a point of the local maxima, you can substitute value here. You will get the local value as 0. Okay, look about this value. Again, you have to find the local extreme values. You can start from here. What is the first derivative is? It's a 3x square minus of 2y is 0. With respect to y is a 3y square minus of 2x is 0. Now after solving, you can see here. what you can do, you can find the value of the x from here, minus 3y square upon 2. I can substitute this value of x here. Now what is the value of this? So you can take y as a common, is a 27y cube minus 8 is 0. So what is the meaning of that? Y is equal to 0, or y is my 2 by 3. So y is my 0, y is and 2 by 3. So when y is equal to 0, what is the value of the x? I can substitute here. So x will be my 0, and when y is equal to 2 by 3, you can substitute x is my minus 2 by 3. So what are the pairs of this? When x is 0, y is also 0. When x is minus 2 by 3, y is my 2 by 3 are the critical points. We can find the value of here, this there. Now there are the two critical points, so we will check this at two values. Firstly at the point 0, 0, and secondly at the point of minus 2 by 3 and plus 2 by 3. We can compute this value at here. You can get as 6 into 0 is 0, and value of this is 0. From here, what is the value of the h1 is 0. From here, what is the value of the h2 is my minus of 4. So clearly says this value is my less than 0. So what is the meaning of that? When it's a less than 0, it means this is my saddle point. So therefore 0, 0 is my saddle point. Look about this value. What is the h1? h1 is my minus of 4. What is the h2? Is a 16, minus of 4 is a 12, which is a greater than 0, and this value is my less than 0. So when h1 is less than 0, h2 is greater than 0, so it's the point of local maxima. So you can see it's a point of local maxima, and the value is my here. So 0, 0 is the point of the saddle point, and this point is my local maximum. Okay, look what the next example are there. So again we can start from here. You can see the critical points. Clearly says that x is my 1, y is equal to 2. So 1, 2 is my critical point, and once you can substitute here. So what is that? h1 is my 2. What is the value of the h2? It's my minus 4. So this value is my less than 0. When h2 is less than 0, what is the meaning of that? It is my saddle point. So therefore 1, 2 is my saddle point of this function. Look at the another point example. So again we can start from here. We can find the first derivative. After solving this, you can get the critical point as 2, minus 1. We can substitute this value. What is the second derivative of this function? So this is my 4, this is my 3, this is my 3, this is my 8. Now clearly says that h1 is my 4, h2 is my 32, minus 9 is 23. Both the values, this value is my positive, this h1 is positive. What is the meaning of that? It is a point of local minima. So hence this is the point of the local minima, and the value is obtained after substituting in the given function. Okay, look about this question. So in this case you have to find the absolute maxima and minima. So which is similar to this kind of the function, but here you can see there is another one condition, that is a boundary lines are there. So this is the boundary region. So how you can solve the maxima, absolute maxima and minima? Up to here we are all finding up to the local maxima and local minima. But how you can find the absolute maxima and minima of the function, that we will see in our next class. That is absolute maxima and minima of the closed bounded region in our next lecture. Till then, you can simply find my playlist Mathematics 1, channel name Dr. Harish Garg, where you can find all those previous videos, topics video, continuity, calculus, and all others are here. I hope you can like, share, and comment this video. You can share with these friends. Best of luck, students. Happy learning.